All right, Wiz, today it's time to get pedantic about some Python, some AI. We're getting Pydantic today. No, I think it's called PydanticAI. Isn't that right?
I think so. I think that's right.
Yeah. So this framework that we're exploring today was built by the same team that actually built Pydantic, something that probably everybody has imported, but maybe not everybody knows exactly what it does, right?
Yeah, it's definitely something you've imported. If you've been following any of our events, if you've been following the AI engineering space at all, you have consciously or not been leveraging Pydantic.
That's right. And we're going to explore like the background of Pydantic today, what it actually means, and how it kind of really set the tone for what came next in web app frameworks. You know, I remember a couple of years ago, people were talking about Flask versus Django versus FastAPI, and this was sort of a big discussion. And, you know, FastAPI is sort of the leader in web app frameworks today. And one of the key things that we want to do is we want to be a little pedantic about the Python behind the scenes when we're building web apps, right? And it turns out that we want to do the same thing when we build AI applications. That's sort of the big idea here, something like that.
That's right. Yeah. I mean, you said it all. That's that's the way she blows.
That's right. So as we're building ever more complex applications, the data validation needs explode. And, you know, PydanticAI and the team, they said, hey, this framework, we didn't see anything as good as what we're trying to build here. So let's go out and build it ourselves. We're going to see if they did the thing and if they're really bringing it with something unique for the industry. Spoiler alert, it's a pretty solid tool. It can do the thing. It can do the thing like other things can do the thing. Is there anything else that we want to sort of off the bat say about PydanticAI for the audience today?
No, it's capable of creating the applications we would hope it's capable of creating. It is a useful tool. It's a useful tool to have in your tool belt. It is, as of yet, still very early days for the framework, but it does what you'd hope and what you'd dream. So,
and all of you guys that are out there learning new frameworks, I think the key thing that I would love for you guys to take away from today is that you can pick up new frameworks just as easy as you dropped the last framework you were using, as long as you get those core concepts and code underlying the framework. You can pick whatever tool you'd like in your toolbox to build these multi-agent applications today. So we're going to check out another one. Our community asked us about it. We're doing a deep dive. Buckle up. It's time for PydanticAI. Wiz, we'll see you back for some discussions throughout. All right, guys. Today, if you have questions, please do throw them into the Slido link. You want to discuss more depth about Pydantic, about FastAPI, about exactly what underlies PydanticAI or other frameworks and how it compares. We'd love to discuss. We think we'll have a little bit of discussion time at the end. So please do upvote your favorites as well. You can find that link directly in the description box on your viewing platform. If you have questions while we're discussing, please throw them directly into the YouTube live chat. We'll go ahead and vibe out with you. So with that, let's go ahead and get into it today. We're talking PydanticAI, data validation to agents. You know, I was really curious about this team as we kind of got started, and I started hearing about this tool from folks in our courses and in our community. And, you know, I really sought out to kind of understand the context here, and I hope I can lay it out for all of you guys, regardless of your background today. So we want to understand the PydanticAI framework, number one, but really we want to understand where PydanticAI grew out of, starting from Pydantic through FastAPI and now into the framework today. We're not going to talk about it a lot in this session, but the team has gone from a fully open source team and they've raised some cash. They're building a platform. It's a competitive space. There's lots of people doing this. This is their open source tool, and that's what we're going to focus on today. We're going to go way overboard in our multi-agent application to build a multi-agent cat joke app using a totally unnecessary approach, but it should be a lot of fun. So stick around. We'll get Pydantic with Pydantic today. We're really going to kind of really try to set the context right for you guys, so things sort of make sense to a wide array of backgrounds. Then we get into the deets, and we'll build the joke app. Should be a lot of fun. If you got joke ideas, feel free to throw them in the chat. This is the question I kept getting from people. Okay. And I think it was a good marketing job by the Pydantic team. You know, if my team is already using Pydantic, will it be easy to get up to speed on PydanticAI? And this is sort of the genesis of me really wanting to do this tool, because I wasn't sure what the answer was. Well, it turns out that if you look deep enough into any of these agent frameworks, they're basically all using Pydantic behind the scenes. So I don't think it's a one-to-one yes here. Certainly, Pydantic is very, very necessary at a base level. PydanticAI, they're doing their best to bring really a state-of-the-art capability connected with a vibe that is very familiar with us web developers. Okay, so let's talk about Pydantic and let's talk about FastAPI. Let's break this down real simply. So Pydantic is really all about being pedantic about Python. Now, I actually didn't know this until I was preparing this event. So if you didn't know this, you know, I think there's marketing that could have been done maybe on the Pydantic side to make this clearer for people. But now it's obvious, right? Okay, let's get pedantic here. And what we want to be pedantic about is we want to be very persnickety about the data that we're putting in and getting out of our stuff, okay? It's the most widely used data validation library for Python. And what you'll see is it says it's doing data validation through Python type hints, okay? What's that all about? Let's talk about FastAPI for just a moment. FastAPI is like about, well, building APIs fast, right? Let's dig in. FastAPI is a modern, fast web framework for building APIs with Python based on, look at this, standard Python type hints. Oh, okay. So we've got Python type hints. Maybe we should figure out what Python type hints are all about. These are ways that we can annotate the variables that we use. And, you know, we can see a very simple example about annotating the data type here for, like, if we just want to add X and Y. You're sort of annotating that X is an integer, Y is an integer, and my output is going to be an integer. Okay, yeah, great. Like, why does this really matter, though, is the key that we want to sort of start to put into the lock here. Well, you know, Python is what's called a dynamically typed language. And what that means is that the types that we're using, the data types, are not static, right? Okay, easy enough. And when we talk about Python type hints, we're talking about sort of giving ourselves, the programmers, helpful hints. These are sort of cosmetic ways. You could almost think of them as sort of commenting the code that help us to understand what's going on. So, you know, the hints that we get are all about data types, you know, int, float, string, etc. And so we want to really root ourselves in this idea that, you know, Python, it leverages various data types. It can use various data types out of the box. We don't have to define them a priori before we can really get started coding. But when we go to sort of build more complex applications, this starts to become an issue. You see, like, Python was originally designed without this sort of typing. And This is why it became important to get a little more pedantic with this as we started building more complex applications. This is important for instance, in web development in general. Okay, so we can think of these sort of higher level types that we start to deal with, objects, functions, versus the lower level string, float, etc., that we're dealing with all the time now, and we're putting them together in very complex ways. And those of us that sort of aren't from a classic engineering or developer background, you know, it's important to understand when we say something like web dev, we're talking about sort of web development. We're talking about building websites and web apps, right? We're talking about really anything we want to build, including LLM applications that are connected to the web. We want to give somebody a public link. Okay, we're doing web dev. So there's front end, there's back end, there's full stack, there's, you know, the whole shebang is there in web dev. Okay, so let's just do a little mini recap here. FastAPI is all about the web framework for building APIs. Now, under the hood, it's leveraging Pydantic to help ensure that everything's in the right data type, to help ensure that everything is going to go well when we're dealing with our application. You see, when we think about tracking the types that we are using as input and output to our applications or to other applications that maybe our application leverages, this idea kind of leads naturally to doing a little validation check. So let's say, for instance, that we have, you know, we have an object and we want to pass it somewhere. You know, object is sort of a key word in programming today, right? An object in Python is just an instance of a class. And a class is kind of the place where you can define like attributes, you know, about data, that's and methods like functions that sort of belong to the object. And when we're dealing with an object, if I want to pass the object somewhere, I need to use the right schema. And I need to sort of really connect all these words in my mind to be able to navigate this space here. You see, when we want to like pass the object somewhere, or when we want to really check if something's going to work, we want to validate that it's going to work before we do it, before we run it, before we execute it. You know, a schema is just sort of a way the object is structured. And so we want to, like, when we're about to run our program at runtime, let's say, we want to make sure all the types of the inputs that I need, everything's Gucci, okay? Everything's ready to go. And so we can think about like APIs or web apps, we might say, as using schemas to validate, in other words, to enforce our correct types. And, you know, we're kind of going down the rabbit hole here. So I want to just say a couple more things, then we'll come back up. Take, for example, JSON. Oftentimes we need a JSON representation. We need a JSON blob that describes the schema of our function. And more, we need this all the time now. You know, we can talk about payloads and signatures and validations and schemas and all this stuff all day long. But I think it's important to come back up now and sort of address the elephant in the room here. Like, how does all of this connect to LLMs and agents? This is the whole crux of PydanticAI, at least ostensibly. Well, if you've been following our channel, then I'm sure you've seen us do some agent stuff with different frameworks. And the one we use probably the most is LangGraph. LangGraph has a great name because it's all about building language agents and language applications as graphs. Well, the idea of sort of building this graph out, what it enabled us to do is it enabled us to sort of add cycles to our applications. And if you look in like LangGraph docs, what you'll see is you'll see a line like this, that LangGraph is a library for building stateful multi-actor applications used to create agent and multi-agent workflows. Okay, keyword stateful here. Well, what is a state? Well, a state is just the condition of something at a specific time. But let's add a little layer of specificity here. Let's consider that actually what we need programmatically is we need a state object, right? And so that state object is the thing we pass around the graph. The state object is the conversation that the agent is having as we pass it around. So what we actually need is we need the state object to be what each place we pass it expects it to be, so that it kind of works in concert with everything else. So we're like, okay, validate it, right? Okay, remember the whole deal here, what we're doing today. We're being a little pedantic today about our Python. Okay, I want to bring in another piece of this just so we can see the full picture. I want to talk a little bit about agents. So recall what we already know about agents. An agent is just a system that can leverage or emulate reasoning to make dynamic decisions in an application flow. And that reasoning and that dynamism, that really comes from the cyclic nature of the apps we build. Also, and as you'll see in PydanticAI, tools are kind of a big part of this. Giving the LLM access to tools is really kind of in large measure what distinguishes an LLM from just an agent, or I should say an agent from just an LLM. And this is true across frameworks. Oftentimes it's hard to distinguish exactly what is meant by an agent versus an LLM other than it has access to tools. And so we can consider a generic reasoning action loop where we have a query, maybe it's a question, it goes to our agent, our LLM, that might take some action. That action is going to be fed back into, as the state object sort of moves through the graph, the conversation thread, the prompt, the context of the LLM. Now, I might know the answer after just one action. I might need to take a few actions. And those actions are generally access to these tools in my toolbox. Maybe I can go search archive. Maybe I can go search generally. Maybe I have specific RAG tools. I can have all kinds of different tools. And really, after I use a tool, I kind of get some result. I get some output. And that observation I make is the actual thing that gets passed back into the conversation thread, the context of the LLM, the agent here. Now, if we zoom in here into where we're actually acting, what I see is that this is actually, this behavior right here where I'm calling the tool is simply a function call. It is a fine-tuned large language model that has been specifically made good at calling functions. You see this reasoning and action, when I sort of combine them into one little step here, that's function calling. And so that this combination of combining reasoning and action into a single step, this function calling is generally called with a specific schema, right? It's called with a JSON schema. And when we call it, sort of at runtime, we might say, I'm checking to make sure, is everything how I think it should be? Do I have each variable in each function that I need in the right type? I'm going to go ahead and do this validation before I pass it to my function call. And in fact, I'm going to do the validation at each step along the way throughout my state object passing from place to place through my agent or multi-agent application. So even tracking state in LangGraph is an example of leveraging Pydantic. Calling a tool is an example of leveraging Pydantic. Wiz, I'd like to call you up for this to sort of have a quick discussion about this. That seems like we probably have to do that with all the frameworks. Do they all use Pydantic?
Like basically, yeah. Pydantic is a let's call it a very common dependency across a lot of really applications generally, right? So, but yes, most agent frameworks are going to leverage Pydantic, right? Because
are there like alternatives that you'll see out there to Pydantic that these things are leveraging?
I'm sure. Yes. I mean, because Pydantic exists,
yeah,
that's all I care about, right? Basically, there is probably other. I know there's like, different Python packages that add like closer to static typing in Python and stuff like that. But in terms of like the catch-all web native, kind of structure, Pydantic is basically the way to go. Someone in chat says data classes. Data classes are great in Python, but they don't have the functionality that we need to really do the rest of the suite that Pydantic helps with, which is become more important as we interact with these APIs that we need to respond in certain ways, or we need to send information to in certain ways.
That's right. So like, just so I'm clear on this, like, as we're sort of like building agent applications and we're passing state around, Pydantic is basically coming in and saying like, hey, wait, do you have all the arguments that you need? Are they all of the right type? Like, is that basically the thing? What else is it doing?
Yep. I mean, there's a bunch of stuff that it does, right?
Yeah,
that we don't, that's silent, we don't really care about, and it's not like data models and stuff like that, right? I mean, there's a lot of it, setting up appropriate schemas for like API calls, things like this. There's a lot of functionality. But it's a very powerful, simple concept, right? Which is that programs need to talk to each other. In order to talk to each other, they need to agree on what they're going to send and receive from and to each other, right? Like me and you, we can have a chat in English, but if I start talking in French or something, it's like there's no we're out of sync, right? If you start talking to me in another language, we're out of sync now, right? We can't talk to each other properly, and this is the kind of problem that Pydantic solves. And this is why when they built their agent framework, like they already have all of this checking that everyone's using. It's kind of like, if everyone's leveraging, why not build it ourselves? And I think this is what we
yeah, because that's what sort of we read, and that's what we'll see in a moment. Is like they said, well, we looked at all these agent frameworks and we don't love any of them, so we're going to build our own.
That's right.
Okay, well, that's a good segue into introducing Pydantic, and we'll take a look under the hood in just a moment, Wiz. All right. let's keep going, guys. So that gets us sort of into this space of Pydantic AI. Let's take a look at what they say. Well, they say Pydantic AI is a Python agent framework designed to make it less painful. Presumably, they found it painful to build production-grade applications with generative AI. Now, just a little context here. You know, they sort of started building their platform and raised money in 2023, and so obviously things have been happening, a lot along the way. And so, it's important to sort of contextualize all of this and sort of put it into its proper time and place. And when we look at Pydantic and their definition of agents, and we look at the different levels of agentic things that they have here, they say, agents are Pydantic AI's primary interface for interacting with LLMs. Okay, all right, so sort of agentic out of the box, let's say. And there's sort of 4 types of applications that we can build with different levels of agentic reasoning. We can have single agent workflows, where this is kind of like the core right now. Obviously, this is what most people are trying to deploy as single agent workflows. This is where you'll find most in the Pydantic docs today. Agent delegation is when we have an agent that's using another agent with tools. We'll show you this in our cat joke creator. And then the programmatic agent handoff is sort of one agent runs, then another application calls another agent. So, that one's pretty straightforward. And then finally, there's the graph-based control flow for the most complex use cases. That sounds familiar. Now, we can look at different frameworks. For instance, we talked about small agents a few weeks ago, and they talked about things like agency levels, right? Where you could have sort of the router, the tool caller, the multi-step agent, true multi-agent workflows. If you go into LangChain's docs, you'll find this discussed as levels of autonomy. We have the simple chain, the router, the state machine, and then the full kind of autonomy. We're in this sort of state machine space today. And so when we see these 4 kind of types, these 4 kind of levels, it's reminiscent of some of the things that we're seeing out there that have become kind of industry best practices. Of course, the 4th level is graphs. And the 4th level, quote, graphs and finite state machines are a powerful abstraction to model, execute, control, and visualize complex workflows. Of course, graphs are simply graphs. They're nodes and edges. They're connected objects, and they create a space around which we pass our state object. As we go from node to node, we could think of a function being called. We could think of a tool being called. We could think of running some application, hitting some other endpoint. When we think about an edge, we could think about paths that we could take. We could think about passing that state object somewhere next. Now, I want to give a shout out to the Pydantic AI team because I really love some of the stuff in their docs. This is just such a great, I know it's a lot of text here, but I want to read it to you guys. Do not use a nail gun unless you need a nail gun. Agree. If Pydantic AI agents are a hammer and multi-agent workflows are a sledgehammer, then graphs are a nail gun. Okay. Sure, nail guns look cooler than hammers. True. But nail guns take a lot more setup than hammers. Also true. And nail guns don't make you a better builder. They just make you a builder with a nail gun. Yeah, that's right. That's right. Lastly, and at the risk of torturing this metaphor, if you're a fan of medieval tools like mallets and untyped Python, boom, punchline of the day. First one. You probably won't like nail guns or our approach to graph. But then again, if you're not a fan of type hints in Python, you've probably already bounced off Pydantic AI to use one of the toy agent frameworks. Love that. Good luck, and feel free to borrow my sledgehammer when you realize you need it. Shout out to the Pydantic AI team for crushing it in their docs. Absolutely love that. Now, it is important, this idea, to ask yourself, do I really need agents? And like most of the time, it's like, nah. But, you know, they're awesome. And so we have people building with them all the time in our class just for that reason. And we like to build with them for that reason as well. Not with our enterprise clients, but, you know, for fun, for funsies. The last thing I want to do a quick little discussion-reno on is like, this is also the key guiding principle, I think, to a lot of the stuff that they're doing. They said, hey, we built Pydantic AI to bring that FastAPI feeling to Gen AI app development. So I want to bring Wiz back up. We talked about vibes last week, Wiz. We talked about saying things like, make it more menacing. I want to feel this. And one of the key things was like, well, what does that mean exactly? And it's like, doesn't matter. Doesn't matter. I think it does matter what it means here. And I wonder what that FastAPI feeling means to you, if you could articulate it.
Yeah, I mean, basically, we're just looking at a bunch of like decorated, classes and functions. The way that we set up the actual Pydantic, agent graph, to spoil the build a little bit, right, is it feels like we are building an application in FastAPI, right? And I think that's meant as a big positive, obviously. Like that's a very good thing. So if you're used to the kind of Pydantic fast ecosystem, I feel like this is a great framework to start with, right? Because it's not as much a mind bend, right, as you might have if you're going to frameworks that felt different. Like LangGraph feels different, right? LlamaIndex feels super different, so this idea is that it is familiar structures, familiar setups, and then we kind of like at the end we add this little graph thing that like ties it all together, right? So yeah.
Okay, so then the feeling of it is really just like, like, man, that was a FastAPI right there. Like, I mean, versus the alternative. I mean,
yeah.
What did you expect going into Pydantic AI with this?
I will say, and I think the note that the in the docs captures this well, right? You're getting exactly what you would expect. Like this feels like you're using Pydantic. This feels like you're building an application leveraging the same patterns we see all over the place in FastAPI. They're not the same library at all, to be clear, but they use similar patterns, right? So they feel similar.
It feels similar. Okay.
And I think that's like if you go into this having an expectation about what using Pydantic is, this will meet that expectation. If you have no idea, you might look at this and say, I don't understand it, or care. Please let me use like LangGraph, which is on the face of it a lot more straightforward, right? Like a lot easier to grok, even if you're not familiar at all with designing web applications or applications that leverage the web.
I see. In other words, quote, if you're not a fan of type hints in Python, you've probably already bounced off Pydantic AI use one of the toy frameworks out there. Okay, go ahead and stay up here, Wiz, because I just want to show everybody that we have a build, and it's time to go ahead and get into it today. We built a joke app, and we got jokes today. So this was actually from their docs. Again, their docs are great. There was a kind of a simple joke app that didn't use enough agents. So we thought, let's just make it a little bit more multi-agentic and let's do graphs for fun. So with that, Wiz, take it away. We got jokes today.
Oh, we got jokes. Okay. You're looking at my notebook. Perfect. Okay, so listen. If you're not familiar with Pydantic, it's going to look like a lot of code. Okay, it's not really a lot of code. It's just the pattern that they use. So when we look at the dependencies, you're going to notice, right, that we have PydanticAI. We're also using Logfire and dev tools. Logfire is kind of like, we'll talk about it, but it's like a way that we can log some of our calls. It's not like Langsmith, right? It's not. It's more like weights and biases traces, if anything. The idea, though, is that we have just these 3 imports. Now, what I will say is that Pydantic is coming with a lot of, similar to early LangChain days, right? PydanticAI is coming with a ton of dependencies that are included out of the box. So it is a little huge, but that's to be expected. It's early. Okay. Then we go to our actual OpenAI API key, and then we go to Logfire API. Then we're going to use Anthropic just because it's new. Why not? Who cares? There you go. Okay. We'll also go to our Nest async IO, and then we have a wall of imports. Wall of imports is important because it is a big wall of imports. We're going to then configure our Logfire. So this is what Logfire looks like, right? It looks an awful lot like every other tracing, application, but the idea is that we can see what's going on. So that's what Logfire is doing. We'll talk about it more in a second. So the first thing we need to do is we can set up our joke generator agent. So this is an agent that sets up joke generators. 1 second here. I'm going to go ahead and share this notebook so that you guys have access to it. We provided this in the materials, but you should see it in the chat now. Perfect. Okay. The basically with Claude, right? So Claude is our joke generator LLM. We are going to use this as an agent. You can see it's just agent. That means it's an agent. Good job, Pydantic, for naming. You'll also notice that we use instrument equals true. This instrument thing is good because it's going to help us log out to our PydanticAI application. Okay, next we're going to have our data class. Now, this is going to be our state, right? So our agent's going to have some idea of state. State's useful because we have a graph. You can see that we have this graph the state that's going to have our joke, our agent messages, our evaluate agent messages, our number of attempts, and our number of max attempts. This feels very similar to LangGraph, right? So we have some state, we set up some information about our state, boom, Bob's your uncle, we're off. The next thing we need to do is actually create our joke generator agent, which is going to be in our node. Yes, the node is going to be like in LangGraph, right? Just to tie us back to something more familiar, it's just a thing that does a unit of work, right? You can see that it's going to expect that it's going to be a base node that's going to have some joke state that should be brought into it, joke state defined here. We're going to have this feedback string, and then we're going to actually do some kind of run here, right? So this run is what we're going to use to actually create some jokes. You can see here that we have make up a joke about cats. It should be both dope and funny. And then we have a feedback prompt. Our feedback prompt is going to be to provide feedback to the agent if in case the joke that it makes is not dope or funny. Once we go to our kind of next step, we're just going to run the agent, right? So you see here, this node, all it does is it takes in some state as input, right? Potentially some feedback, and then it makes a joke. That's it. Classic. Just calls the LLM right in there. There you go. That's all it does. We love it. And then it adds some modification to state. Classic. Then it's going to return a node. So this is more similar to LlamaIndex. LlamaIndex, right, has this idea where like each step is going to return the next step. This is similar to, it's going to return an event which is associated with the step. In this case, we just return the straight up next node. So this is a little bit different than other frameworks, but the idea is the way we build our graph is actually in these node classes. So we take our original node and then we return the next node. Of course, we can return more than one next node if in case there is more than one next node. We'll see an example of that in a moment. Then we're going to create a new state or a new node. This node is going to be our produced joke node. All it's going to do is it's going to evaluate our node. Very cool. We love it. We're going to create a new class, which is going to be our evaluation result. Our evaluation result is going to contain the results of our evaluation. We'll also create a new evaluate agent. This is going to use GPT 4.5 preview. Because that model, while not like amazing at reasoning tasks, something like that, the vibes are correct, right? So it's kind of funny, it's kind of memey, should do a great job at telling us if these jokes are good. Then this is the same thing as we saw before. You'll notice though that our result type is going to be this evaluation result. So we can actually pass this data class directly into our result type in order to ensure that we're getting these results filled by our LLM. And we do this all without needing to define, JSON blobs, everything like that. So very, very cool. Okay. Then we create our evaluate node, which is going to evaluate. You'll notice that this node is either going to go to congratulate, reprimand, or end. Easy peasy. And then we're going to use our evaluate node or agent. We're going to run it. We're going to get everything that we need back, and then we're either going to go to end if we've reached our max attempts, or we're going to go to congratulate if our result was funny and dope, or we'll go to reprimand if in case our result was not funny or dope. Very cool. Okay. Not funny and dope, to be fair. Okay, so this is the idea. But once again, we go from the evaluate node to either end, congratulate, or reprimand, right? So we're defining the graph as we define the nodes. Each node is going to have some number of potential destination nodes. Last, we're going to set congratulate. If we did a good job, we're going to go to end, and we're going to print some feedback. If we go reprimand, which means we did not do a good job, we're going to go back to our joke generator. We're going to start the process again. So what we've done is we've set up all of our nodes, and we've told each node where that node should go next, right? This is the idea. And now we can collect all these nodes in our nodes for our graph that we create. And then we can include what state our graph is going to have. And then we can look at our beautiful mermaid plot, which looks kind of, kind of messy, but that's okay. The idea is pretty simple. We go to joke generator. From there, we go to evaluate. From evaluate, we either are done because we've hit max, retries, or we get reprimanded to go back to the joke generator to evaluate again, or we just go to congratulate and then we win and we go to the end. The idea, though, is that each of these we don't set up separately like edges in our graph, right? All of these nodes know where to go next. That's the easy part. Okay, then we're gonna run the thing. So what we do is we start our state, we create our initial node, we create some history, we use Logfire in order to log this out, and then while true, classic while true, we just get the next node. And we do this until we get the node end. Once we get the node end, we are good to finish, and we're gonna print out the final state. This is the idea, right? This is what we're focused on. Basically, we just keep calling next on this graph until we hit the end node, and then we can see here, right? So we get this joke. Why did the cat become a famous DJ? Because they had the perfect beats and always knew how to drop the meow mix. I don't love that one. Okay, so I agree with the agent. The agent said it's cute, but it lacks a punchy impact. So we created a new one. What's a cat's favorite electronic music genre? Per step. They love those deep bass drops because it makes the mice drop too. That one's funnier for sure. I don't know if it's like really super funny, but you know what? The LLM tried its best. 4.5 said good enough. I like it. and then we can see the final state. But that's it, right? We create nodes. The nodes tell us what node we're going to next, and then we tie them together with a graph. It is like the boilerplate is maybe a little bit to get adjusted to, but the actual logic is straightforward, right? In the node, we just do some action that involves an LLM or not, and then we go to the node we want to go at the end of it. That's it. There's your thing. That's the build. Let's go. I'll pass back to Greg. Before I do, though, I have to ask you to like and subscribe. Click the little bell notification. We're here every Wednesday. All right, back to Greg.
All right. Thanks, Wiz. Okay. Yeah. I don't know if we knocked it out of the park with any of those, but we got some jokes. Okay. So good stuff. Let's go ahead and take a close look at what we can expect just real quick from the Pydantic AI team. Wiz did mention Logfire, and I think it's important to just mention that this is like October last year. This is their observability platform. They raised their Series A, great stuff. So this came out October. And then Samuel Colvin, the founder and, basically creator of Pydantic, had a couple things that are interesting that I think are worth noting. Many of you reading our recent Logfire launch and Series A announcement may be wondering, wait, aren't you the team behind Pydantic, the data validation library? Why are you venturing into observability? Fair question. Let me try to explain. And he says things like, I've been frustrated by existing logging and monitoring tools for years. He says, in many ways, observability feels like it's stuck where the rest of infra was 15 years ago. The recent surge of observability for AI tools aren't much better. And I think it again is important to put this into context. They're all improving rapidly and they're all competing with each other. Chainlit created Literal, LangGraph, LangChain created Langsmith. LlamaIndex has got Llama Cloud. Everybody's building these platforms out, and it's unclear, who's got the best one or who's going to win, and all of that. But I wanted to do Pydantic AI because I love their open source vibes as a team. And they did something really, really cool that's incredibly unique. Not only is he, talking about observability companies like them don't do it like us, which is dope. And then also admitting that it's not always a simple business decision to sort of decide to charge for stuff. Hey, you're telling me, my man, Samuel, shout out to you on that one. But also they're doing a lot at Pydantic to sort of build in the open source thing. So one of the cool things is this Pydantic open source fund, where they have this open source pledge where every developer they have on their team that they're paying, they're going to invest $2,000 a year towards maintaining open source projects. So they had 11 devs when they wrote this. That was 22 grand per year in 2024. I hope to see this grow. That's a cool concept. And I encourage that team to, keep building, shipping, and sharing. And I wish them the best of luck. So, in conclusion today, being pedantic about your Python applications and about your agentic applications, probably dope. Pydantic AI totally does the thing. It's still very early in their journey. They're still in beta or they're coming out of beta, whether you're looking at their Pydantic AI open source framework or their Pydantic Logfire observability platform. They have hilarious docs, great vibes, especially as far as observability platforms go. And, I love that they're telling us what's real. Don't rush to add more complexity, but we still have the same advice for you guys. If you've been watching their stuff, pick the one you're most excited about. If it's Pydantic and you want that, FastAPI feeling, dope. If not, also dope. So let's go ahead and get to questions here, Wiz. We've got some time for questions, as we mentioned. So if you've got them, please do let us know what you think. But Wiz, we've looked at a lot of frameworks over the past years. I'm starting to see a consistency in the patterns here, where there's an open source framework, it does orchestration, and then they're selling us an observability platform, and then maybe we got to pay for that when we run out of free credits. It seems like that's sort of the the consistent pattern of innovation here. It really does come down to just picking your favorite one that you can work the quickest with today in 2025. Is that right?
I think so. I mean, it's like, it's hard to know. So we're in a weird space, right? So it's very new, this space, even though it feels maybe not new because like it's been 18 months or 24 months or whatever it's been, right? But I just I don't know where, you know, I don't have the answer here.
That's right. That's right. I mean, because when we started, I mean, this idea of LLM ops was the big buzzword. It's kind of died as a buzzword. I mean, some people still say it, but you know, it certainly like had its moment in the sun, and then it kind of went away. But it seems like all these observability platforms, that's kind of what they are doing. And I'm also struck by, you know, when we go and we look at the more classic ML observability platforms versus the LLM specific observability platforms, while there is some overlap, it's not clear to me that just because you are good at ML ops, you're going to be good at LLM ops. Would you say that's a fair assessment?
Yes, I think that's a fair assessment. So everything's so nascent, right? So everything's very young, everything's very new. But I expect that you're correct, because we are still we're feeling everything out, which means that nothing is solved yet. If nothing is solved, that means that like the possibility space is infinite, right? I expect that the skill sets are going to be largely interchangeable for the next, I don't know, 36 months or so. And your job title might switch a lot, but the actual core capabilities and the core competencies are going to be very similar, you know?
Yeah. It does feel like things are sort of maturing to a certain point where it's kind of like if you know the concepts and code that underlie it, you know, the frameworks matter less than ever. It's kind of what it feels like to me. Like, I don't know if you guys, you know, that are watching today or that watch later kind of feel that it's easy to pick up new frameworks, but I feel like it is getting easier. And now we're getting things like PydanticAI that comes in and says, well, we didn't really like that ability for ourselves to pick up framework X, Y, or Z. So we built our own framework that is more aligned with the flavors and vibes we already like when we're building. That to me is like, if there's something that's new and novel here, that is it. It's like taking their lens of the world of data validation, of FastAPI, and people that are building with these tools all the time. What's the best way for people that are building with those tools to get into LLMs and AI? Maybe this is a good way for them to get into it. Like, back to the original question of the day, just because my team is very comfortable and familiar with Pydantic, is it a good idea for them to start with? Maybe, you know, but also just because they import Pydantic doesn't mean they really know about Pydantic.
Yeah.
Right? It's tough. It's tough. I
don't think you're correct, right? So it's just the thing where whatever is the least friction path, I think, is the best way to get in for anybody. If PydanticAI feels familiar to you, feels comfortable, feels like home, then it's the best way. All these frameworks, I love that the docs are so pointed.
Oh,
that's fun. We love that kind of language, but at the end of the day, they all do precisely the same thing in a very, very similar way, right? So whatever you're most happy with is going to be the framework that you should choose for now. Once, you know, we have some thoughts and feelings about, the LangX ecosystem, right? But, when you're trying to get in, whatever is the least difficult or mind-bending is absolutely the way you should get in.
Yeah. And basically like being a little bit ahead of another player in the game 6 months ahead feels like you're really far ahead right now, because so much happens in 6 months, so much. Think about the model providers. It's not that extreme, but it's similar. And I expect to see a similar sort of like, like battling for supremacy, ultimately when these things get really, really mature. So we do have a couple questions that I want to answer before we get out of here. Is like from Anonymous, in the build, why did you use built-in data class to define nodes and not base model from Pydantic or even Pydantic's data class?
Basically, this is from their docs. So I did what they did in their docs. The actual Pydanticing is being handled behind the scenes through their AI library. So when we pass in things like that data class, it's being converted to a model on the back end. Just makes it easier for us to use. So that's basically the idea. Having that be the case is what is most effective. I'm not sure if we lost Greg or if I have dropped, but if in case we've lost Greg, I will lead you guys out. Basically, we're going to wrap. Thank you very much for attending our event today. It has been our pleasure to walk you through everything that we've done with PydanticAI. It's useful. Use it if you have comfortability and familiarity with the tooling. It feels like home, right? If you're used to that Pydantic UI, and that's our event for today. It looks like Dr. Craig's back if he wants one last word, and we'll go ahead and see you next time from my point of view.
Yeah. Thanks, Wiz. Appreciate that. Got fully owned by whatever weird windstorm is happening here. So I do want to let you guys know about a very, very cool premiere that we have coming up. It's this Friday at 7 p.m. Pacific, where we're going to be open sourcing a course that we just taught last November, December. It's called LLM Engineering, and it basically walks you through everything you need from pre-training all the way up to distillation, merging, and creating your own small language model. So it really goes from the transformer all the way up to the LLM edge. And it's a great concepts and code way to start digging in, see what it's looks like behind the scenes in our live courses. And you can join the premiere live on YouTube on Friday at 7 p.m. Pacific. We'd love to see you there in the chat. Additionally, if you're interested in joining us for our upcoming AI Engineering Bootcamp, definitely get your application in now, because we've recently expanded our challenge. The challenge is harder than ever. There's more steps than ever. You've got to build and deploy your first application and fine-tune your first LLM before we can allow you in. These things are becoming table stakes, and we've got to continue to keep up with the state of the art. We've recently released a brand new curriculum that we'd love to share with you guys as well. And if you are curious about it, please do check it out. Otherwise, we can't wait to see you guys next week. We've got a very special series on optimization, where we're going to sort of dig into the most basic foundational elements of all the way up to exactly how we build, ship, and share things like DeepSeek R1 today. It's going to take all year. We're going to do one a month, and we're kicking it off next week. So that's it for today. Thanks for joining us for PydanticAI. Keep building, shipping, and sharing. And in the meantime, we'll do the same. See you guys on Friday and next week for our optimization series kickoff. Bye, everybody.